Hello, good morning. Today is 4th of November and 2020. The day is Wednesday and right now I am with the 10 Matric class. The subject we are studying is Physics 5054. We are on chapter number 14 and my name is Ferhan Mazher. Okay, today the first topic on which we will be working is EMF. So the first thing is, what is EMF? You see, EMF is called electromotive force. This stands for the word electromotive force, but don't confuse it that it's a force. No, it's not a force. It is basically, the unit of the EMF is volt. It's like potential difference. But the EMF means the potential difference across the terminals of the battery. For example, if you have a battery, for example, let me show you that this is a cell. It's the positive side, this is the negative side, suppose. And suppose I directly connect it with a voltmeter. This is the symbol for the voltmeter. So this voltmeter will directly note down that what is the potential difference between the terminals of the battery. The potential difference between the terminal, the positive terminal and the negative terminal of the battery, that is known as the EMF of the battery. That is known as an electromotive force of the battery. It means the voltage or the potential of the battery. Okay? So, EMF. The definition of the EMF is very interesting. You see, what happens in a cell or what happens in a battery? In a cell or in a battery, the cell or the battery, remember these words, okay? The cell or the battery, they are the source of electric energy. They provide you electric energy, and in your chemistry or might be in your physics you have studied that the function of the cell is that it has chemical energy in it. And what the cell do, it converts the chemical energy into electric energy. So a chemical reaction takes place in a cell and it converts the chemical energy into electric energy. Okay? So when you define the EMF of the cell, this concept will be very important, that the chemical energy is converted into electric energy. This is the function of the cell. It has chemical energy, it converts into electric energy. So EMF is the amount of electric energy, chemical energy converted into electric energy. The amount of chemical energy converted into electric energy when unit charge flows through the cell. Okay? EMF of the cell is the amount of chemical energy converted into electric energy when unit charge flows through the cell. This is one definition of the EMF. So the EMF, or is measured in volts, is equals to the work done or the energy divided by the amount of charge. So definition of the EMF is the amount of chemical energy converted into electric energy when unit charge flows through the cell. The EMF can be also defined in another way. The EMF is the work done by the cell or work done by the battery to move unit charge in a closed circuit. The energy provided by the battery, the energy provided by the cell to the unit charge to move it around in a closed circuit. The energy provided to the unit charge by the cell is known as EMF of the cell. EMF is measured in volt. So you understand this? Do you understand? So this is EMF. If you want to measure the EMF of a battery, you will connect the voltmeter. Remember these two names. I'm talking about an instrument whose name is voltmeter. Whenever this is the name of the instrument, it's represented like this. This is the symbol for the voltmeter. Whenever you want to measure two things, one is the potential difference or voltage or EMF. Wherever you want to measure potential difference across a resistor, if you want to measure the voltage drop across a resistor, if you want to measure the EMF of a cell, the instrument which I will use, that is called voltmeter. And this is the symbol for the voltmeter. And remember, the voltmeter is always connected parallel. It is connected parallel wherever you want to measure the voltage difference, wherever you want to find out the potential difference. The voltmeter should be connected parallel to that appliance. It should be connected parallel to that resistance. It should be connected parallel to that cell. For example, let me show you. For example, let's say, suppose that I have suppose this is a battery and this is the positive terminal, this is the negative terminal, and here is lamp number 1, here is another lamp number 2, here is lamp number 3. For example, if you want to measure EMF of the battery, you will connect the voltmeter parallel to the battery. So I will connect the voltmeter. This is how you connect the voltmeter parallel to the battery. For example, let me say this is lamp 1, this is lamp 2, this is lamp 3. If you want to measure the voltage drop, potential difference, or voltage across a lamp, here lamp number 1, I will do this by using instrument voltmeter, and the voltmeter should be connected parallel. So how you do that? I will connect a voltmeter parallel to the, like this, let me call it voltmeter number 1. If you want to find out the voltage drop across the lamp 2, you will connect a voltmeter parallel to the lamp number 2. If you want to find out the voltage drop or potential difference across the lamp number 3, here you put a voltmeter parallel to the lamp 3. So the important thing is, when you want to measure voltage drop, when you want to measure potential difference, when you want to measure EMF, we use the instrument voltmeter, and the voltmeter is always connected parallel. It is always connected parallel. In the same way, you remember yesterday we learned that the ammeter is an instrument which is used to measure the current. But the ammeter is always connected in series. And I told you that these two words are very MCQs. Ammeter is connected in series with the appliance through which you want to measure the current. Voltmeter, you connect parallel to the appliance whose potential difference or potential drop you want to measure. So always connect voltmeter in parallel and ammeter in series. Okay? So it's very, very important thing. So that's it. But one last point I would like to tell you again. You see, one last thing about the same topic. You see, if you study two things, electromotive force, and another thing you studied is potential difference or potential drop or voltage difference. Same thing. EMF is also measured in volt. Potential difference is also measured in volt. They both have the same unit. Okay? Don't confuse it with the force. Its name is electromotive force, but it's basically potential difference. EMF is a potential difference across the terminals of a battery. But the potential difference is not across the battery. It is the potential difference across the terminals of an appliance. It's the potential difference. It's the potential drop across a resistor, an appliance, anything which is using electric energy. But the EMF is particularly the potential difference across the battery, the terminals of the battery. This EMF tells you what is the potential difference between the terminals of the battery. Potential difference tells you the potential difference between the terminals of an appliance. Okay, another thing. When you define EMF, you use the word that the chemical energy converted into electric energy, and you say per unit charge. These are the words you use. When you define potential difference, you say electric energy converted into any other form of energy. And you also use the word per unit charge. Very important thing. The definition seems to be the same. When you define EMF, you say the amount of chemical energy converted into electric energy when unit charge flows through the cell. EMF. But what is potential difference? It is the electric energy converted into any other form of energy when unit charge flows through a resistor, an appliance, a lamp, or a speaker, or a heater. Electric energy converted into any other form of energy. So these are the few differences and similarities between them. Don't confuse them with each other. So thank you very much. This was about measuring the voltage difference, EMF, and the current. So thank you. Have a good day. God bless you.